Hello everyone, this is Solina Noon and today I will walk you through my assignment number 5. So this assignment number 5 that I was given, that I was receiving is about given the state table of a non-deterministic finite state automaton and a string, determine whether this string is recognized by the automaton. So basically, before we dive into any further the program that I wrote itself for this, I would like to remind you about the NFA or the non-deterministic finite state automaton. In the book definition, it says that a non-deterministic finite state automaton M consists of a set S of states, an input of a bed I, a transition function F that assigns a set of state to each pair of state and input, a starting state S0, and a subset F of S consisting of the final states. So basically, in order to understand this in a simple way, we want to look at the specifications of the NFA. Now, by looking at the NFA specification, I would like to make a comparison between the DFA, which is the non-deterministic finite state automaton, and the NFA. As you know that these two machines basically are the finite state automaton are the finite state machine with no output, and that means that um, if you have a machine and you have a string, basically you will just feed in this string into the machine, and basically it will not just give you a result or anything like an output in each state. It will just going through different state until it hit to certain state. I mean, like certain state that we call an accepting state. So once that string, going through different state, tracing on certain path, it would just hit onto a state that whether it's determined as a acceptance state or whether it's gonna hit onto a state um, that is not considered as an acceptable state, like a state that has no next state. So that is the definitions of an finite automata, and the comparison between the DFA and the NFA is that the DFA it will just only uh, receive one next state per uh, per input value with the same type. Let's say if you have the input value of a 0, and then you go to S1, but you cannot go from S0 to S2 with the same input value as 0. However, the NFA gives you more ability to overcome this. So the NFA let you go on to different multiple choices of the next state. Let's say the same way, like you could, if you have the input of 0, you can go to S0 to S1 or S0 to S2. So you have more choice on that. So the machine itself has more choice. Now, let us take a look of this example, and this example will be used in my program also. So we're gonna use this example of the machine and the language to build a state table onto my program. So we have a language. So the machine below will will accept any language that consists a string at least one. So number one, at least one number one. Now you see this machine below that I drew. the graph one, it has three states: S0, S1, S2. So S0 is the starting state and S2 is the acceptance state, denoted as in green and double circle. So basically, how do you know that this machine is an NFA? By one glance, you will know it because from S0, if you have input of 1, it will just go to multiple state, right? It will just go to S1, S0 itself, and S2. Now, and how do you know that it's consists? Um, how do you know that it's accept only a language that consists only at least one? Well, basically, if you look at the arrow or the input onto the acceptance state, on the adjacent state here, from the acceptance state onto the adjacent state, so between there, you will see that the input that it comes into the acceptance state is only one. So any path that you would take from S0, it would just have to cross this path that has the input of 1, right? So that's how you would recognize that quick. And now let us look at the correspond state table down here. On the left column, we have a state from S0 to S2. On the right columns, we have the input and its correspond next state. S0, 1, 0, and 1. And if you look at this table, you can see that it's matching, because if you start on S0, the input of 0 is going to be S0 itself, S0, 0. And if you have the input of 1, it's going to go on to S0, S1 to S1, S0 to S1, S0 to S2. So 1, 2, 3. And if it's on S1, input 0, S0, input 1 going to S2. Now if it's on S2, and the input of S2 is 0, it's going to go on to S1. And if the input of 1, it's going to loop into itself again. S2 again. So as you see, it's on the state table here. Now, the program that I built here, that I'm going to show you later, I built from C++ programming. And C++ has this useful function, which is called, it's not a function, it's a class that you can call. And it's basically, it's called an ordered map. So an ordered map is like a hash table where you have a key and a value pair. It's easy to build the table because if you use the hash table, you can trace, just have an input string as a state, and then once you pass it, you can retrieve the value quickly. And yes, so I use a key here as a state value, and the value itself is a two-dimensional vector. So vector, if you never heard of vector, in the C++ programming, it's a dynamic array that you can easily add and remove element dynamically. That's why I prefer than using the either pointer or over over the static array. So my first dimensional vector would be indexing the input set, and the second vector, I'm storing the value of that correspond to each index of the input or the string of the input. Now let us take a look at my programming code itself. So on this main main program in mains. This is where the main program happening. Basically, this section is all about declaration of the necessary variable for usage, such as the final state, uh, the input string value, the static state, um, and the number of state. And this section is to prompt the user to enter the necessary information, such as the total number of state, the input state set, the final state. And in this section, I just prompt the user to enter of each value of state for or you call the next state for input value for each input value. And down here is once the user is being prompted, it's gonna print out the state table for the user. So we print out the header first and then the body of the table. And last but not least, this section is just prompt the user to enter a string and then take that string broken into transform that string into a vector of string and then pass it through a function called check language. So check language will basically will passing the string information onto the hash table that we have built before, and then it's gonna trace that string to different state of the hash table itself. Now let us run the function. Let us run the program. So I didn't know how we would run this program on Windows, but I know only on Mac because I'm using Mac. So basically, if you open your terminal and you route your way to from your terminal to the directory that store this file, which is called asm5.cpp. So once you route onto the location that store this file, you could type in this information, this string value here, cgg gcc asm5.cpp-o asm5. So what this command does is that it would just transfer. It would just translate this source code into a binary executable code. So right now, this is a compiler section. We are compiling right now. Once you finish, you could, in order to run this program, you would type ./asm5. Now, it's asking for the input of the state. So, for instance, we're building this table, right? So it has 3 states: S1, S0, S1, S2, S3. So 3 state, and the input state set would be 0 and 1. Input final state. So in this case, S2 is the final state that we determine. Now we are currently on S0 right now. It's our current state. If current state is S0 and we receive the input of 0, we would have all the S, and we would have our next state. So we would have our next state is S0 and 1, input of 1, S0, S2, S1, S2. Then current state is S1. If we put 0, it's on S1 itself. S2, 1 S2. Now let's see. You see that the table that I'm building here is correspond to the table that is shown on this document. Let us enter a string 000. Let's see if this string accepted by this machine or not. So as you see that it give a trace for you. So it trace 1, 2, 3, 3, 0, and it determined that it's not accepted by the NFA. So you see like it's 0, 0, 0, 0. So it will never reach to S2. Now let us give and now it's gonna prompt you to ask whether you want to try a different string or not. If not, just press N. If you want to continue, it will say yes by using the same machine or the same state table. So yes. So now let us try 1. Input a string 1. Now 1, this time this machine accept, right? Even though you see the path of the trace path, you see that it has a state of 0, 0 here, and S1, S0. S0 is going, if you have the input of 1, it's going on to S0. If you have the input of 1, it's S1 again, S2. So S0, S1, S2. So it's accepted. Even though this part is not really accepted yet or non-accepted because it's not reachable to the acceptance state, it's still fine. It's still showing you the path, every possible path to the accepted one, which is from S1, S0 to S2. So it keep like tracing down the line. Now let us try other string value. 1, 0, 1. So it shows that it's accepted by the NFA with all the traceable path. Now, as you see that this machine is accept only at least one input string of 1. So this machine does accept that value, does accept that language. And now let's quit from this program. One thing I wanna call out is that this machine can only have one acceptance state. I haven't put or build an additional mechanism for storing the multiple acceptance state yet. So if you have any question, please let me know, and thank you for your time. Bye.